All right, you are welcome to the live class. You are welcome. You are welcome. So today we'll be focusing on another important aspect of JAMB chemistry. As far as JAMB chemistry is concerned, you cannot run away from this particular word aspect. So we'll be focusing on them. So for right now, this is 31 seconds of starting the live video. So I'll be going to the board to start teaching, and by the grace of God, subsequently other people will join us in the live session. So this video or this live session promise to be very effective, and it promised to be very self-explanatory, and apart from this we will also solve past questions and answers on this particular word topic. So you are welcome to another live session again on JAMB chemistry made simple. So first of all, we'll be starting with the first topic, which is what acids, base, and salt. The acid, the base, and the salt. We'll be starting on what we'll be focusing on what acid, base, and what salt. So acid, base, and salt is a question or is a topic that question must always come out from every year. If you check your past questions, you get to see at least 3 or 4 questions as far as chemistry is concerned about what acid, base, and what salt. So we'll be starting with the first word, acid. Before we move on to base, then we'll move on to what salt. So first of all, what is what acid? Acid in our normal day or in our normal living activities, we get to know that what acid substances what taste what sour. Acids are associated with what sour what taste. So acids are associated with what sour taste. It is not base, it is not what salt, but rather what acid. So what is what an acid? We all know what an acid is, right? We say what an acid is a substance which produces what hydrogen ion as the only positive what ion. An acid is a substance. An acid is a substance. An acid is a substance. Is a substance which produces hydrogen ion. Which produces hydrogen ion. Produces what? Hydrogen ion as the only positive charged word ion. As the only word positive word ion. As the only positive word ion. An acid is a substance which produces what? Hydrogen ion. That is what H plus. That is what H plus. As the only positive word ion. And in that case, acid is classified into 2. We have what 2 classes of what acid. We have the word organic word acids, and we have the word inorganic word acids. The organic acids is from the name organic, simply means they are what natural, and the inorganic acid means they are what synthetic, and they can be what produced either in the lab or what in the what industry. So we have what 2 classes of what acid. We have the word organic acids, and we have the word inorganic word acids. So let's talk about the organic acids. Number 1, we are going to talk about the organic acids and their what source. It is very important that you know this organic acid and their what source. Let me check if we have anybody that have joined the live. All right, we have someone in the live. We are welcome. You are welcome. You are welcome. You are welcome to the live section. So we are talking about what the what organic acids and their what source. So for the first organic acid, we are going to draw a table. So let's say, I don't know whether I can see from here. So let's say organic acid, I will draw a line. We say what source. So we are going to mention the organic acid here, and we are going to write down the source. The source simply means where can we find this organic acid in what nature. So number 1, we have what ethanoic acid as the first example of organic acid. We have the word ethanoic acid. For the ethanoic acid, the source of ethanoic acid is what vinegar. Vinegar is the source of what ethanoic acid. Vinegar is the source of what ethanoic acid. We are going to see past questions on this because we are going to solve questions. You get to see that sources of what organic acid is a most question. Check your past questions. You are going to see it. You are going to see an organic acid. They will be asking you what a source, or they can ask you what a source, and they will ask you where you can which organic acid is it from. So we have what? Ethanoic acid, and it is gotten from what? Vinegar. We have the second one, which is what? Lactic acid. We have the what? Lactic acid. And the lactic acid is simply gotten from what? Milk. So we have what? Organic lactic acid. It is gotten from what? Milk. We also have citric acid. Citric acid. It is gotten from what? Lime. It also gotten from what? Lemon. So you have what? Citric acid. Citric acid. So the citric acid can either be gotten from what? Lime. It can also be gotten from what? Lemon. So anyone you see there is what? Correct. So for the purpose of this class, let's put the both of them. We say what? Lime or what? Melon. Sorry, lemon. So you can acid can either be gotten from what? Lime or what? Lemon. Please note, citric acid is not gotten from orange. This is where a lot of people used to get it wrong. They will say, oh, because the binomial nomenclature for orange is what? Citrus what? Sinensis. The binomial nomenclature for orange is what? Citrus what? Sinensis. And the moment people now hear citric acid, they will automatically believe that this citric acid is what? Gotten from what? Oranges. Please note, citric acid is not gotten from orange. Rather, it is gotten from what? Lime or from what? Lemon. So the next organic acid is what? The amino what? Acid. We say what? The amino what? Acid. So the amino acid is the what? The end product of what? End product of what? Protein. So the amino acid is simply gotten from what? Protein. So the beans you eat, the meat you eat, being broken down, being denaturized from their original states, this is the end product of what? Amino or what? Acid. So protein or amino acid is gotten from what? Protein. The next one there we have is what? Fatty acids. Fatty acid. From the name, fatty what? Acid. Fatty acid will be simply gotten from what? Fat and what? Oil. They break down the what? Fat and what? Oil. Fat and what? Oil. And also note this important part. Fat is a solid lipid, while oil is a what? Liquid what? Lipid. It is important to notice fat is a solid lipid, while oil is what? A liquid what? Lipid. Please note it down. We also have the last one, which is what? Which the source is what? Orange. When we talk about what? Orange. So let me first of all write the source. So we have what? Orange. And the organic acid that is gotten from orange is what is known as what? The ascorbic what? Acid. Ascorbic what? Acid. Ascorbic what? Acid. Ascorbic what? Acid. The ascorbic acid is also known as what? Vitamin C. Vitamin what? C. So we say what? Vitamin what? C is what? Ascorbic what? Acid. So ethanoic acid gotten from vinegar, lactic acid gotten from milk, citric acid gotten from lime or lemon, amino acid gotten from protein, fatty acid gotten from fat and oil, and ascorbic acid, also known as vitamin C, is gotten from what? Orange. So it is very important that you know this word classification. So the second classification, we have the organic acid and the inorganic acid. The second classification, which is the inorganic acid. The inorganic acid is simply saying we have the hydro, right? You have the hydrochloride, right? The hydrochloride is gotten from the addition of hydrogen and chlorine. All these ones are synthetic or synthesized. That means we can produce them. But our major focus, the inorganic acid, is not of major focus. The major focus at this particular point, where JAMB will be focusing their questions on, is going to be the organic acid and their various sources. So let's talk about the types of acid. There's a difference between the classification and the type of acid. There's a difference between classification and type. So for the two types of acid, we have the strong acid and we have the weak acid. It is also very important that you know this point. So the strong acid ionizes completely in water. Strong acid, we have the strong acid. Strong acid. We say this ionizes completely in water. So the strong acid ionizes completely in what? Water. The strong acid ionizes what? Completely in water. A popular example of strong acid, which I know and I believe you also know, is what is known as what? The hydrochloric what? Acid. The hydrochloric acid is a very what? Strong acid, and it ionizes what? Completely in what? Water. Where we have what? Our what? HCl, giving us a forward reaction of what? Hydrogen ion. Remember that is what an acid is, right? It what? Ionizes what? Completely. You say an acid is a substance which what produces what? Hydrogen ion as the only positive what? Ion. So this is what hydrochloric acid, which we say is a what? Strong acid. So we want to see whether when this hydrochloric acid is being broken down, it's going to give us what? Only what? Hydrogen ion as a positive, as the only positive what? Ion. So in this particular point, where our hydrochloric acid is being broken down, we are going to have what? Our what? H plus our what? Chlorine, and what? Chlorine, the oxidation number of chlorine is what? Minus. The oxidation number of chlorine is what? Minus. But let me give you a point, although this one is not in this particular what? Topic of or what I'm saying. It was supposed to be in that yesterday class. Let note that oxidation number of every element, the oxidation number of every element at their neutral state or at their ground state is what? 0. Note that point. The oxidation number of every element at their ground or neutral state is what? 0. But that is not what we are doing today. That is just an extra knowledge. So as you can see, hydrochloric acid being ionized give us what? Hydrogen ion as the word, only what? Positive what? Ion, sorry, and it will dissolve what? Completely. So we also have the word weak acid. For the weak acid ionizes what? Partially. They don't what? Dissolve what? Fully. As you can see here, so the strong acid ionizes completely, but the weak acid what? Ionizes what? Partially. So let's move on from here. And let me see how many people are currently in the live section. Let me see. At least if you are following, please just drop in your comment. If you are following, just drop in your comment. Is there any way you need clarification? Let me actually know you are following the class. So let me drop this key point again. If a large amount of water, take note to, I'm going to counter this particular statement I'm going to make when in the course of this explanation. If a large amount of water is added to an acid, it is known as what? Dilution. Large amount of water plus an acid, it is equals to what? Dilution. When a large amount of water is added to an acid, it is known as what? A dilution. Please take note. But when a small amount of water, yes, plus what? Acid, it is equals to what? Concentration. Or what? Concentrated. Don't say concentrated what? Acid, concentrated what? Base, which in turn we are going to get it. So a concentrated what? Acid is one in which what? A little amount of water or a small amount of water is added to the what? Acid. But a dilution is when what? A large amount of water is added to what? An acid. You understand my point? So that is just how what it is. Then let's talk about the next point. So let me clean here so that I'll be using all this space too. So let's talk about the next point, which is here. I'm just giving you key points. That is what I am doing. From the JAMB past questions, which I am with at least 20 questions from this particular topic. We are going to solve 20 questions from this particular topic. So that's where I am getting the key point from. There's also another concept that is known as the basicity of what? An acid. The basicity of what? An acid. So we say what? Basicity of what? An acid. Basicity of an acid. The basicity of what? An acid. So what is what? Basicity of what? An acid. The basicity of an acid is the number of what? Replaceable what? Hydrogen what? Ions in one molecule of what? An acid. Is the number of what? This is the basicity of an acid is simply the number of replaceable what? Is simply the number of what? Replaceable what? Hydrogen ion. Replace. Alright. Simply the number of what? Replaceable what? Hydrogen ion. It's simply the number of what? Replaceable what? Hydrogen what? Replaceable hydrogen what? Ion in one molecule of an acid. in one molecule. I hope you can see from there, please. Hope you can see from there. In one molecule, this thing is wetting my job. This thing is wetting my job. In one molecule of an acid, in one, my duster is wet, so it's wetting my job. In one molecule of what? An acid. So that is what the basicity is. So we say what the basicity of an acid is simply the number of replaceable hydrogen ion in one molecule of what? An acid. So let's give example of this acid and the numbers of what? Hydrogen ions that is what produced and their what? Basicity. When we want to give at least, I have here with me 2 acids with their what? Replaceable what? Hydrogen what? Ions and their what? Basicity. So let's go. We have what? The acid. Let me change. Let me change this chalk. They are not good at all. This chalk is wet. Alright, I'm back. So we have what? The acid. We have the acid. We have the what? Ions produced. We have the ions produced. And we have the what? Basicity. So let's rule our line. Hope you can see clear from what I am writing. So we have the acids. This is where we are going to write the acid. We are going to write the amount, the ions that is produced here and their what? Basicity. So the first acid on my list is what is known as what? The hydrochloric acid. So we want to write the amount of what? The ions that is what produced. So the ion that is produced here is simply what? Our H plus and our Cl what? Minus. So as you can see here, we have our acid, which is what? Hydrochloric acid. The ions produced here is what? H plus and what? Cl minus. This is to tell you that how many ions can be replaceable here. We just have what? One ion that can be what? Hydrogen ion that can be what? Replaceable. From the what? Definition of what? Basicity. Simply the number of what? Replaceable what? Hydrogen ion. And if you check here, we just have one hydrogen ion that I can replace. If we check, just have one hydrogen ion that I can replace. So the basicity of hydrochloric acid is what? 1, or what is known as what? Monobasic. We say what? Monobasic. Monobasic or what? 1. That is what we have here. We also have the second compound, which is known as what? Tetra, also what? Sulfate what? 6. We have what? Tetra, also what? Sulfate what? 6. Which is what? Our what? H2 what? SO what? 4. Our what? H2 SO what? 4. This is our H2 what? SO what? 4. So when you check this here, this is what? H2 SO4. What? How many ions that are produced? So let's give the ions that are produced. We have our 2 molecules of what? Hydrogen plus, and we have our sulfate. We have our 2 molecules of hydrogen ions that is produced, and we have our sulfate. And we have our sulfate. So that is what is produced. Let me come behind so I can see whether you're actually saying what I am doing. Okay, it is clear. Thank God. I was skeptical that it's not showing clear. So this is it now. If you check here now, how many hydrogen ions can I replace? It's 2. This is what 2. Our major focus is on what? Hydrogen. Our major focus is on what? Hydrogen what? Ions. So when you check here, we have what? 2 hydrogen ions that can be replaced, and we call it as what? 2. 2 what? We can say the basicity is what? 2, or we can say it is what? Di, because di is what? 2. So we can say what? Dibasic. You can say dibasic or what? 2. You understand? Because it's only 2 hydrogen ion that is here that even in my church mind, if I want to come and remove or I want to come and replace, it's only 2 hydrogen I can what? Replace. Why for that hydrochloric acid? It is just what? 1 hydrogen that I can what? Replace. So that is just it for a concept that is known as what? Basicity of what? An acid. So let's talk about the physical properties of what? Acid. What are those physical properties of what? Acid? That the moment I bring a substance in a glass or container and I keep on this table, you get to see it, and just by looking at it with your eye, you will know that, oh, this is what? An acid. That is what is known as what? The physical properties of what? An acid. So what is the first physical properties of what? An acid. We all know that an acid turns what? What is it? Okay. So let me write, say physical properties. Physical properties. Physical properties. First of all, talking about the physical properties, just as I explained, an acid turns what blue litmus paper what red. An acid turns what blue litmus paper what red. So you say what number one. This is the one that even though you don't know anything about what acid, please just get to know what this. That an acid turns blue litmus what blue litmus. So you can say that blue litmus paper what turns what blue litmus what red. That is what an acid is. The second one is that an acids have what sour what taste. An acid have what sour taste. When you allow your food, they say warm food in the morning, and you refuse to warm that soup in the morning, and you allow it to be what evening, and the food was sour. It is what they are some what acidic. You get to find out that the moment you eat that soup that are sour, it's going to affect you in your belly. You can have a running stomach, or you can even fall sick. That is how you know that you have gotten in contact with an acidic substance. It is the same thing like eating unripe orange. You don't pluck unripe orange and start eating it. It's the same thing like mango. Something that is unripe, you don't start eating unripe mango or whatsoever. So the second property is that an acid have a sour taste. Then the third properties of an acid, that is number 3, is that concentrated acids are very corrosive. So you say what? Concentrated acids. Concentrated acids are very corrosive. If you have to pour, if someone make a mistake, that is why everyone wants to do chemistry practical in the lab. They don't even allow us to go close to concentrated acid, because a little mistake of concentrated acid touching someone's skin is going to peel off that skin. It can even dig it can even bore hole in someone's hand. So a concentrated acid is very very corrosive. There is no play when it comes to concentrated acid. So that is just it. That is the this is the basic physical properties of an acid. So let's clean it and also talk about the chemical properties of acid. How can I know chemically that this is an acid without me going to look at it and using my eye to examine to do that? Oh, this is the physical properties or this is whatsoever. You understand? So how can I know chemically that this is an acid? And that is known as the chemical properties of acid. So let's clean this. Let's clean this and say chemical properties. Let's say chemical properties. So one of the chemical properties of an acid is an acid. Please take note of this. I saw this when I was teaching my JAMB students in our physical class. I saw it and I asked this particular question. I saw it in a past question. We are going to answer it this year. I saw it in the past question. I asked them, and unfortunately, none of them was even able to give me an answer. I felt bad, and I have to go back. I have to go back to acid and base. After finishing acid and base for a very long time, I also have to go back and start giving them this finishing touching, because I got to find out that they were just reading, but they were not getting the main points that JAMB is asking them. So one of the first chemical properties of an acid is that acids react with metals. Acid react with metals. Let me see how many we are currently in our live stream. All right, we are 4. Thank you so much for joining the live stream. Thank you so much for joining the live stream. I really appreciate you. Thank you. So, like I said, acid react with metals, like zinc. That is the first word, metal. Acid react. So, if I want to write react, this is what I'm going to do, please. So, this is react. Acid react because of our bond. This place is not good. So acids react with metals react with metals. With metals like zinc, zinc, iron. So acid react with metals like zinc, iron to liberate or to liberate hydrogen gas. Acid react with metals like zinc, iron to liberate hydrogen gas. In fact, the moment it comes to acids, one of the things or one of our most important joy, or when it comes to acid, like one of the most important things or elements we are looking at when it comes to acid is what? Hydrogen. Hydrogen is one of the most important what? Acid. You get to find out that as we are even talking from the beginning of this class, we are always on mentioning what? Hydrogen, hydrogen, what? Hydrogen, hydrogen. So acid we have in metals like zinc to replace or to liberate what? Hydrogen what? Gas. So let me give you the general reaction of how this is. So we have acid. We have alright. So an alkali is what? Soapy to what? Touch. When you touch an alkali is very, very what? Slippery. It is very, very what? Slippery. Then we also know that they turns what? Red litmus paper what? Blue. And we also know that they are used in what? The soap what? Industries. They are used to make what? Soap. So the alkalis are used in making of what? Soap. So let's move on to the next one, which is what? The measurement of what? Acid. The measurement of acidity is done, or the measurement of acidity or acidity is done using what is known as what? The pH what? Scale. Is done using what is known as what? The pH what? Scale. Let's continue. Is done using what is known as what? The pH what? Scale. Is done using what is known as the pH what? Scale. So the pH scale is simply what? Let's assume it is what? A long line, which is what? The scale being divided in the middle, starting from what? 0 to what? 14. So they are numbered 1, 2, 3, 4, 5, 6, and we have here 7, we have 8, 9, 10, 11, 12, 13. Now, from here, like this, is increasing what? Acidity. Increasing what? Acidity. Increasing acidity. And from here, like this, going forward, is what? Increasing what? Basicity. Increasing what? Basicity. That means 14 is more basic than what? 8. And 1 is more acidic than what? 6. And 7 is known as what? Neutral. 7 is known as what? The neutral. So the 7 is known as what? The neutral. 14 is the what? Basic. 0 or 1 is the what? Very, very what? Acidic. When you say 1 is very, very what? Acidic. So that is just what? It. We also have another concept that is known as the what? Indicators. We also have another concept that is known as what? Indicators. So what are indicators? Indicators are simply what? Weak organic acids or bases which will produce what? Different colors in what? Solution according to the what? Hydrogen ion concentration in that what? Solution. We say what? Indicators are weak organic. Indicators are what? Weak organic acid or what? Base. Weak organic acid or what? Base. A weak acid or what? Base, which will produce